So the other day, I was trying to find some pictures for my history project, but they all looked like this. As I was trying to find a good picture, I was falling asleep and could not tell them apart. So I decided, why not just color them in? Yeah, Photoshop is not gonna cut it. I knew I needed a fast and simple way to colorize images. So I decided to build an AI image colorizer, but in only 5 hours since my history project was due the next day. To break this down, I have a to-do list right here. Simple, right? First, let's set everything up. And remember, NumPy is used for numerical operations and handling arrays, which will be helpful in image reshaping, which we'll see later. Argparse is used for parsing command line arguments, and OpenCV is used for computer vision tasks like image processing. This file defines the model architecture, while this file contains the trained weights, and this file contains points used for color quantization. Now we need to define file paths and arguments. Here we're defining the file, and the section also uses os.path.join to make sure it's compatible across different operating systems like Windows, macOS, or Linux. Now we need to set up some arguments. This makes sure the model actually has an image to colorize. Now at the command line, specifying the path to the input grayscale image is mandatory, and if it's not specified, this will return. Now we need to prepare the model. As we have our path set up, we now need to load the pre-trained model. First, we just need to print a message to show that the loading process has begun. Now we need a function that reads both the network architecture and its weights into memory, creating a model object called net that can be called in the future. This will be used for mapping grayscale to color in colorization tasks and will represent predefined color clusters for creating a colorized version of grayscale images. Now we need to prepare specific layers of the network by setting their parameters. This layer is responsible for predicting color channels, while this layer is adjusted to rebalance color outputs. The points are reshaped and assigned to the corresponding layer to help with mapping input values. Now it's time to colorize the actual image. We're almost there. But first we need to prepare the image. The input grayscale image is read and normalized by dividing by 255. The image is then converted from BGR, OpenCV's default, to LAB color space, which separates its luminance value L from color information, where A and B channels represent different values, and A represents red and green values, while B represents blue and yellow values. The image is then resized to 224 by 224 pixels for input into the neural network. The L channel is isolated and adjusted by subtracting 50 to center it around 0. Now to actually colorize, the L channel is set as input to the neural network after converting it into a blob format, which is suitable for DNN processing. The network performs a forward pass to predict the A and B channels, which are then shifted back to their original shape. To create the output image, we need to combine channels and convert the image back to BGR. The original L channel is combined with the predicted A and B channels into a single LAB image. This is converted back to BGR format for display using OpenCV, and values are clipped to make sure that they're within valid ranges before scaling back up to a standard pixel value, which is between 0 and 255. Now to finally get back a colored image, we can write this. And from this, the original grayscale image and its colorized version are displayed in separate windows. The program waits for a key press before closing the windows. And that's it. Now, if I put in the image I needed for my history project, I can now get this. If you want to see this entire project, check out my GitHub repo in the description and additional sources to find out where this project came from. And that's all. Thanks for watching.